lines, and we're going to be talking about the slope of those lines. Before we get into that, we're going to just do a little bit of notes and fill in the blanks about what slope is and the best way to calculate it when given a picture. Right? Slope, if you're talking about it just in layman terms, is how steep something is, or it's its steepness. So when we're talking about the slope of a line, we're talking about its steepness. For instance, if you're on a hill and it goes down really fast, this is a steep hill. Right? If you're on a road that's nice and flat, you'd be like, oh, this is very steep at all. And that's what it is. So steepness and slope, they're like the same thing. So if it's steepness, in math, we have to define it a little bit better than steepness, right? You have to define it to be able to calculate it. So we define it as a ratio in the vertical change divided by the horizontal change. Now, we don't usually use the words vertical change. We just say it's the rise. So the rise is how much something changes when you're going up or down. And we say instead of horizontal, we say the run. That's how much something goes from left to right. I'll show you in a second what that looks like when you talk about rise and run on a graph. But it gives us our first formula to use, and you're going to get a bunch of them. And it's that slope equals rise divided by run. That's what we mean when we know ratios. It just means division. How to calculate rise and run. This is going to be instructions on how to calculate it, but we're going to do a demo which might help. So when calculating the rise and run of a line, we always go from a left point to a right. Whenever possible, we go left to right, left to right, left to right, left to right. And the reason we do that is it keeps our negatives really simple for us. So if we have to go up from left to right, so to get from the left point to the right point, if we go upwards, we say that the slope is positive. If we have to go down from left to right, we say that the slope is negative. Up is positive, down is negative, but that only works if you're going left to right. Otherwise, it's backwards. If you're going from right to left, it's reverse of that. That's why it's so important that when we're doing our slope, you'll see in a couple examples, you just go left to right. It's a reading a book. The last thing before we really jump into it is that we don't write slope very often. Right? Mathematicians are lazy people. So instead of writing slope all the time, they use the letter M. M means slope. And then they'll put a little subscript to tell you what they're talking about. So if they did something like this, M and then a little tiny 1, that means the slope of line 1. That's how they would describe it. That's how you're going to see it. Alright, on the next slide we have 6 examples. And we're going to try to calculate the slope of all 6 examples. I'll do 1 and 2 with you, you'll do 3, and then I'll do 4 and 5 with you, and you'll do 6. On the bottom you'll see there's a chart that you need to fill out. This means slope of line 1, right? M1. You look up, you find line 1's right here. They want you to calculate this. The first thing, and you have a beautiful picture like this, is you need to find 2 perfect points on your line. Now when I say perfect point, I mean it has to be somewhere in the intersections on the grid. Right? There's all these little crossroads on a grid. A perfect point is a part on your line that crosses one of those intersections. Like that right there. Another perfect point would be that right there. So those 2 are perfect points. They cross right in the intersection of the grid. Once you have 2 points, you start on the left point, and you work your way to the right point by going up and then over. You go up 1, 2, and you over 1, 2, 3. That's the rise and the run. Because you went up it's a positive rise. And how many units did we go? 2. So the rise equaled 2. When we went left to right, the run was 1, 2, 3 units. So we say the run equals 3. Slope is rise divided by run. 2 divided by 3 is the answer to the first slope. When you're given a picture, slope is easy to find. This is the easiest formula we have for slope. It takes a few times to see it before you really catch on, but once you have it, people are pretty good at the rise over run. Let's look at line 2. So on line 2 over here, I want to find 2 perfect points. I have a perfect point here. I don't know another perfect point for quite a while, all the way over there. I then start on the left point every single time. And I go up as high as I need to until I can start going over. So I go up. 1, 2, 3, 4, 5. Up 5. And then I go over 1, 2. That means my rise over run would be 5 divided by 2. Rise divided by run. Now some people look at this and like for me, my brain, it just works to go up or down and then left, or sorry, and then right. Some people like to go right first and then up or down. So for instance, if you look at this same question, somebody might look at that and instead of going up and over, they would rather go over 2 and then up 5. They got a rise of 5 and a run of 2, just like I got a rise of 5 and a run of 2. So as long as you're going left to right, it doesn't matter which one you do first. My brain works better to do rise first. That's why I'll always go up or down first and then move left to right. Some people prefer to move sideways first and then go up or down. It's your choice. It doesn't matter. As long as you're going left to right. On line 3, I want you to try to calculate the slope. Yeah.
Wait, so then if you went up, but if you're like, let's go to the left, because that goes right, then that'd be negative?
We'll do negatives in a second. We're going to get negatives in a second. So try line 3 on your own. Line 3, I look at it. I find 2 perfect points. I've labeled them. I pick the one on the left to start at, and I work my way to the one on the right. So I go up 1, to the side 3. My rise is 1, divided by my run is 3. 1 over 3. All right, slope 4 we're going to do together because it's a little bit different, and it kind of runs into the problem that Alyssa was talking about or alluding to, which is when do you get negative slopes, right? Because these were all positive numbers every time. We're going to do line 4. We're going to find 2 dots. We're going to follow the same rules we did before. I find a dot here and here. I'm going to start on the left dot and work my way to the right dot. This time, though, to get from left to right, which way do I have to go? I got to go down instead of up. That's when you get negatives. So if you have to go down to get to the point on the right, that's called a negative slope. So I go down 2 to the right 3. That means my slope is negative 2 over 3. Because I went down, then to the right. Did that answer the question?
Yeah, but if that going to the right.
Always go to the right.
Okay, yeah, never mind.
That's how you fix that problem. Because you're right, like you could go from the right point to the left point, but then you go up, don't you?
Yeah.
And that'll screw you up. So if you always go to the right, you only have to worry about ups and downs, and you never have to worry about lefts and rights. Technically, going left is negative. So if I started at the right point, I could have gone negative 3, positive 2. And it would still give me a negative fraction overall. It's just the negative's in a different spot. That's why I try to tell people always go left to right, and then you never get confused on is it positive, is it negative, right? So just always go left to right and you're good. You just have to worry about up and down. Okay, there's something else about line 4. Did anybody try line 4 on their own before I did it? A few people. Did anybody use a different point? Yeah. Because there's different perfect points in this graph. There's one right there, there's one right there. So there's actually different perfect points. You should notice that from point to point, it's still down 2 over 3. Okay? Negative 2, 3 to the right. But what if we did this question and you didn't see 2 points right next to each other? What if you picked these as your perfect points? Because I said just pick 2 perfect points. I never said pick 2 that are closest to each other. Just pick 2. And sometimes those are the 2 points people see. Well, let's try rise over run when we go that far. What we're going to get is we're going to get 1, 2, 3, 4, 5, 6, negative 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That rise over run is negative 6 over 9. Very different than negative 2 over 3. Yeah, Peyton. You just have to reduce it. Yeah, that's exactly what it is. These fractions are the same thing. They're equivalent fractions. If you put them in your calculator, they both equal negative 0.66666 repeated. This one is reduced in the simplest form. So make sure you write your fractions for rise over run in simplest form. That's the answer that would be on a test. Negative 2 over 3. Negative 6 over 9 is not wrong, it just needs to be reduced. Your calculator can reduce them. Remember, you put it in your calculator, you get a decimal, and you go math, frac. That's the first option. And it'll change anything into the simplest fraction for it. Alright, I'll do number 5 for you, and then you do 6 on your own. So if I look at 5, I need to pick 2 perfect points. I'm going to pick this one, it's a little bit off, okay, and this one. I need to do rise over run. I go down 1, 2, 3, 4, 5. Rise is negative 5. To the right 2. So because I went down, it was negative. Went to the right 2. It's negative 5 over 2. I want you to try number 6 on your own. I'll give number 6 a try. 6, if I look at it, I find 2 points on it. One right here, one right here. I go from left to right. Start on this side, go to the right, and go down 1 to the right. That means my rise is negative 1, my run is 3. How many people got that? Doing good? Awesome. Now, we spend a lot of time on slope, and we're going to do a few more. The reason being is by the end of the unit, what we're going to be doing is creating equations. To create a proper equation, you have to calculate the proper slope. And if you're wishy-washy, if you're like 50%, then you're going to really struggle by the end of the unit. If you've got it down pat, then it's really going to be good for you. Now, before we slide on to the next one, I want to just look at these answers that we have. If you look at the first 3 graphs, what do you notice about all the slopes? They're all positive. What if you look at the next 3? They're all negative. So, that, if you look at the lines, is not a coincidence. You should be able to look at a line. They're also the exact same numbers, yeah. Positive 2 over 3, negative 2 over 3. It's the same thing, just one's up, one's down. You should be able to look at a line and right away be like, that's a positive slope or that's a negative slope. When you look at a line, going from left to right, if it's going upwards, it's always going to be a positive slope. If you look at a graph from left to right and it looks like it's headed downwards, always negative. So you should be able to look at a graph and be like, these ones are positive, these guys are all positive because of the way that they all trend up. This one's all negative because they all trend down as you move further along. There's two special cases. The special cases are horizontal and vertical lines. We're going to talk about their slopes. We're going to start with horizontal. We're going to start by trying to calculate the slope like we just did for the other questions. So if you look at this horizontal line AB, and I said calculate the slope. Well, the first thing you do is you pick two perfect points. There's a lot of perfect points here. I'm just going to pick those two. And then say, okay, if you want to get the slope of AB, so M of AB, that's what that means, slope line A to B. I need to calculate the rise. From the left point to the right point, how many up do I have to go? 0. It goes 0 up. Divided by, how many did I have to go over? 1, 2, 3. Awesome. Now, I could have picked any 2 points on this line, and I always would have got a rise of 0. Because it's a horizontal line. None of these I ever have to go up. And the run doesn't even matter. The reason it doesn't matter is if you have 0 and you divide it by any number, it's always equal to 0. I could have picked 2 points on the very end of the line, but it's still 0. Look at any of these other lines. That means M of CD. I can pick any 2 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still going to be 0 divided by 10 equals 0. Because there's never a rise in a horizontal line. If there's never a rise, all horizontal lines have a slope of 0. And that makes sense, and I'll talk about why it makes sense in layman terms. The very first thing we said was slope is steepness. I'm standing on a horizontal line right now, right, the floor. If I said, how steep is this floor? You would say, it's not steep at all. There's 0 steepness to it. It's not downhill, uphill, it's nothing. This has 0 steepness because it's flat. It's horizontal. Vertical lines are a little bit tricky. People do good with horizontal lines. Vertical lines, not so much. So we're going to try to calculate the slope of a vertical line. Let's do GH. So let's find the slope of G to H. I'm going to pick 2 points on the line GH. I'm going to go there, I'm going to go there. I need to calculate my rise or my run. I'm going to start at the top point, go to the bottom, go 1, 2, 3, 4, down, divided by how many to the right did I have to go to get to that second point? 0. 0, right? There is no run in a vertical line. They're always going to be right on top of each other. Well, that's not good enough. You could have gone up, and that would have worked too. So you could have gone from the bottom to the top and got positive 4. That's a good question. The reason it doesn't matter is your run is always going to be 0. And can you divide by 0? No. You can't, right? If you tried that in your calculator, if you went -4 divided by 0, it'd just say error. It's not possible in math. Remember we did the thing with the Siri, and it talks about Cookie Monster trying to split it between 0 of his friends, and he has no cookies left, and he cries or something. Can't divide by 0. We have a special term for that. Okay? We say it's undetermined. Right? So when you say a vertical line segment have an undetermined slope. Sorry, undefined. You might see undetermined in some books if you are using a textbook to study, but undefined is definitely what you'll see. It's undefined because it's not possible to calculate it. You can't divide by 0. Now, speaking in layman's terms, right? We're talking about steepness of something. You're standing on the edge of a cliff and you're looking straight down. There's nothing below you. And if I asked you, like, how steep is that? Like, how do you describe that? It's very steep. I don't know. It's perfectly steep. Like, I can't even walk on it. It's so steep. I just fall right off the edge. That's an undefined steepness, an undefined slope. You will need to know that term. Right? You'll need to know both of those. You will get horizontal lines given to you. You will be given vertical lines. And you need to understand that the slope is 0 for horizontal, undefined for vertical. And that's the term that you'll see on a test in this class. Undetermined means the same thing. All right, some questions. These are typical types of questions you could get for a basic slope question. The first one is talking about drawing a line. Okay, it says draw a line on a grid which passes through point -4, 2, and has a slope of -2, 3. Anytime that you're drawing a line in this unit, they should always give you a starting point for that line. This is my starting point. I need to go mark -4, 2 somewhere on this graph. -4 for next line means go left 4, 2 means go up 2. There's my first starting point. That's -4, 2. For left 2 up. The next thing they should give you is like a map to another point. That map is your slope. Slope should tell you how to get to another point. If your slope equals -2/3, what two things did they tell you? They told you that your rise is -2 and your run is +3. They told you that if you go from your starting point and you go down 2 and run for 3, that's another point on your line. And you could keep doing that. So I could go down 2 more, and I can go over 3 more, and find that point. I could keep going forever. But that's a lot of work to find all those points by going down 2, over 3, down 2, over 3. So instead what we can do is we can create a line. And we create a line by taking a straight edge and connecting the dots. So this would be like, oh, here we go. Hold on. That blue line is a line that goes through point -4, 2 and has a slope of -2/3. Make sure that you use a straight edge to draw your lines. If you freehand it like me, you're going to notice that you're close, but you're slightly off. So for instance, if I look at this point right here, I should go perfectly through the point that's 2 down and 3 over. Notice that I actually missed it a little bit. If I go 2 down and 3 over, I missed it a little bit. If I go 2 down and 3 over, I should have been right here. See how I'm getting further and further off? It's because I freehanded. So 1 down 2 over 3, I'm getting further and further away from how it should have actually looked. So make sure you use a straight edge, a ruler. Some people use the back of their calculator, but make sure it's just a perfectly flat straight edge. All right, practice question number 1. They give you a point in the slope. I want you to try to draw the line. Okay, so try to draw a second line on here that has that point and that slope. Question. It says, draw a line that passes through -5, -4. So I have to mark that on my spot right. That's -5, -4. I know my line has to go through that point. The next thing I know is that my slope is 3/4. That means if I went up 3 and to the right 4, I should find another point. 3, 1, 2, 3, 4. Right there. I could also go backwards. So I could go left 4, 1, 2, 3, 4, and down 3, 1, 2, 3, and get that point down there. Right? So you could go backwards as long as you're going to the left and then down. It works too. That's why we try to always keep things going to the right. It just makes positive and negative so much easier. But if you notice, at this point, 3 up, 4 over, it works, right? So you kind of work backwards too. The next thing is I have to draw a line that connects the dots. I mainly put this extra dot down here so I can draw a straight line to the best of my ability. That's pretty good. I'm getting pretty good at it. Yeah, right? Like, the trick is to look where you're going. It's like driving a car. I was like, I try to project. I start here, but I'm looking here, and then I just go draw. I try my best. And sometimes it turns out okay, and sometimes it's crazy. That line that I just drew follows my rules. Like, I could check my answer. Did I go through the point -5, -4? Yes, I did. Does that line have a slope of 3/4? It goes up 3/4, definitely. So you can actually check your work, too. All right, the next question is a different type of question. It doesn't have a graph. It's just a word problem, basically. It's also something you'll for sure see on a test. And like this will come back up. It's also something that people really struggle with when it comes to the test time, for whatever reason. There's a bunch of practice problems in your practice booklet that are similarly worded. So I definitely make sure you practice those ones. But what it does is that if a line has a slope of -2/3, and you found that it actually has a rise of 10, what could be the run of that line? This is working off of, remember that line where we had equivalence? It was -2/3, -6/9? That's what this is working off of. That same concept, that your slope could be calculated using different numbers but still get the same ratio. So what I do when I get a problem like this is I take the slope they gave me and I write it out. -2/3. That's what they said the slope has to equal. But in reality, they said it has a rise of 10. So it equals 10 divided by, do we know what the run is? No. We don't know something math, we call it x. So what I set up is an equivalent fraction right next to it. Now there's two ways to solve this. What some people like to see is they compare the tops. And they say, all right, if this is 2 and this is 10, how did I get from 2 to 10? I multiplied by 5. That means on the bottom, to get from 3 to x, I need to multiply by 5. So what should x be? X should equal 50. The run should equal 50. Now that's one way to do it. Oh, sorry. I missed something. Anybody see what I missed? The negative number. I missed the negative number. If they had a negative slope, I need a negative slope. But they said the rise was +10. So the run has to be -15 so that your slope is negative. Okay, so yeah, you definitely need to have that included. If your slope was negative, the other slope should also have a negative in either the rise or the run, one or the other. Yeah.
Cross multiply and divide order consequence.
That's the other way to do it. So personally, I would never do it this way. I just don't see it like that. I see this as cross multiply and divide. I'm also a math teacher who's very mathy, so I understand why that works. I also get that for you guys, it might just be easier to see these are ratios to try to do it like that. The problem is this method is really hard to do with decimals. It's hard sometimes to see what decimals need to be to multiply. So the way you could do this my way, or exactly what Bryce just said, was you set up your fraction the exact same. And if the x is on the bottom, like it is here, then I need to multiply the 3 up, times by 3, and then divide the -2 down. So that I have 10 times 3 divided by -2. Cross multiply and then divide. If the x is on the top, then all you have to do is multiply the other number up. You only have to do one cross multiply and then divide. This one's like a double because the x was on the bottom, so I had to switch both numbers. If you calculate that, it also equals -50. To each their own. Both ways will work. This way will work a little bit easier with decimals. Be a little hard with the other method to find it. On practice question number 2, I want you to try to solve for the run on that question. So go ahead and give it a shot. Okay. Got a question here. Gave me the slope, so I write that out as a fraction. My slope was 5/3. Now they're giving me a situation. They're giving me a rise, and they're asking for a run. They could do the other way around. They could give me a run and ask for a rise as well. They also don't have to use the word rise. They could say it has a vertical change of 20. That means rise. So they could try to mix it up by just changing the wording a little bit. For instance, this could be a skateboard ramp. And they could say, hey, Mr. Kennedy built a skateboard ramp that had a slope of 5/3. When he measured it, the thing actually goes up 20. It has a vertical change of 20. How long of a run does that ramp have to have? Right? They could do something crazy like that. So just understand they could use different words, but at the end of the day, they always mean rise and run. They said the rise is 20, so I put that on the top. What is the run? So x goes on the bottom. When you look at that, you could do it the ratio way. The way to get from 5 to 20 is to multiply by 4. So then 4 times 3 would be your answer. Or you could cross multiply. So multiply that 3 to the top. And then divide that 5 to the bottom. 20 times 3 divided by 5 should equal, you should have a run of 12. How many people got that one? That's good. That will be on a test. Like you will see a question similar to that pop up for sure.